So now let's talk about the states of matter, right? So we mentioned that we're going to focus on three, but we'll talk about four. We'll talk about plasma briefly. So right here, we're talking about solid. Solid, again, think of water, right? That's our most common example, but anything that is solid, like your phone, the table, a piece of metal, right? Those are all solids at room temperature here on Earth. And some other planet, they might be, if the planet is hotter or colder, they might be different. But here, solids are things like that. But let's think of ice, for example. The solid state of matter consists of particles that are tightly packed in a regular pattern. And that's why you see it kind of looks like a block right there in this picture, right? With all those little red particles. That's kind of like an ice cube. It's very solid, very structured. These particles vibrate, so they don't move from place to place, but they vibrate while they're kind of stuck like that. And so solids have a definite shape and a definite volume. And what that means is if you put an ice cube, and no matter what shape of a container you put that ice cube, it's going to stay stuck in that cube shape because that's what a solid does, right? And what that's a fixed shape. And what they mean by fixed volume is it's going to take up the same amount of space no matter what container you put it in, right? So if you have like a little small chunk of ice and you put that little ice cube into, like, you have it in a little cup and you move it to a gallon, well, it's still going to be that same little size, right? It's not going to grow to the size of the gallon just because you move it into a gallon, right? So it has a definite volume. Again, it doesn't get bigger in size. A solid does not change shape unless you cut it, bend it, or break it, right? So it's going to stay in that shape unless you do one of these things to it. And so then we have matter, or sorry, we have liquid, right? Another state of matter. The liquid state of matter, and think about this, like it goes from solid to liquid when you add temperature to it, when you add heat to it, right? The temperature rises, it starts to melt, and it goes from a solid to a liquid. The liquid state of matter consists of particles that are closely packed together, right? They vibrate, they move with ease, and they flow past each other. I always like to think of these as like the ball pit at Chuck E. Cheese or something like that, where you have all those balls in the pit and they just kind of move around each other and they swirl around each other. They're not stuck together, right? They can move past each other. That's kind of how water is. Liquids do not have their own shape, but they take the shape of the container, giving the liquid a definite volume. Right. So for this one right here, you see it's not rigid, right? It's not stuck in a block shape like the solid. It isn't a fixed shape, right? It can turn into whatever shape you put it in, what of the container that you put it in. So if you have it in a round container, it turns round. If you have it like in a square container or cubed container, it turns cubed. So that's what it means that it has no fixed shape, right? It'll take the shape of whatever container you put it in, but it does have a fixed volume. So that means if you're going from you put a cup of water, right, and it's in a cup, it's the size, it just takes up that cup. But if you move it to the gallon, it's not all of a sudden going to grow in volume. It's not going to take up the whole gallon, right? It's still going to be a cup of water. So again, it'll take whatever shape container you put it in because it has no fixed shape, but it does have a fixed volume. So that means it won't take up more space if you move it into a larger container, right? And then you have gas. So gas is a state of matter that has like the most energy compared to a solid, an ice cube, and liquid water. Right. The gaseous state of matter consists of particles that are very far apart. So these things spread far apart from each other, as far apart as they can. Right. That is why if you put a lid and you're boiling it, and all of a sudden the lid starts kind of lifting off the pot, it's because all that steam is trying to rise out of there. Right? It's trying to get out of there, and so it's trying to spread itself apart. It moves freely at high speeds and they're well separated. Gases have no definite size or shape and take the shape of the container, filling the entire space inside the container. So this is what it's saying is it's not rigid like the way a solid is. It has no fixed shape. So that means it'll take the shape of whatever container you put it in, but also no fixed volume. The more space you give gas, the more space it's going to take, right? So it will grow in size. It'll take up more space, I guess, if you put it in a larger container. And then, really quick, we're not going to focus too much on plasma, but it's just an ionized gas, meaning it has positive and negative charges throughout it, right? Plasmas are composed of electrically charged particles, and they're good conductors of electricity. Plasmas are also affected by magnetic fields. And so you'll find these in, again, plasma TVs and other things around your home that, the state that they are plasma or that they contain plasma. But again, we're not going to focus on this one too much as a solid, liquid, and gas.